Today we're going to do a system of equations, and we're going to solve it using method 2 that I introduced in class, which was the substitution method. When you use the substitution method, you only have to get one variable by itself. Unlike the setting equal to, where you had to get both equations, you had to get a variable by itself. With substitution, you only have to use one equation and you only have to get one variable by itself. So if you look at these two equations here, I always want to get the variable by itself. That's easier. Now if you choose to get y by itself every time, that's fine. It might just be a little extra work. So if we look at this, you can see here that x is going to be the easiest to get by itself. So I'm going to solve the top one for x. So if I have x plus 10y equals negative 14, to get x by itself, I'm going to move the 10y over by subtracting. That way I have negative 14 minus 10y. Now I have x by itself here, so again I'm not going to use this top one anymore. And since I'm substituting, x is here and that's an x also in the second equation. If x equals this negative 14 minus 10y, I'm going to substitute it in to the other equation. So I have 3 times negative 14 minus 10y plus 5y equals negative 22. So again, I have used the same equation, it's just that for x, I've substituted what I know x to be. And I know x is negative 14 minus 10y. Now I distribute here. So 3 times 14 is 42, so this is negative 42 minus 30y plus 5y equals negative 22. And now I'll combine my like terms. So negative 42, I have negative 30 plus 5, which is negative 25y. That equals negative 22. I'll add the 42 over. That way I can get y by itself. So I have negative 25y equals 20. Then divide both sides by negative 25. And 20 divided by negative 25 in simplest fraction form is negative 4/5. So I know y is negative 4/5. This is a different problem. Y is negative 4/5. However, since I have a system here, I also need to get x. So I've already substituted x in, and I figured out y. Well, now that I have y, I'm going to substitute it back in to get x. And I know x is what we have here, negative 14 minus 10y. So I'm going to substitute in for y this time at negative 4/5. Then I can just punch that into my calculator. So I have negative 14 minus 10 times negative 4/5. Notice I punched it in exactly like I wrote it. And so my answer is negative 6. So x equals negative 6 and y equals negative 4/5. We'll do one more. You'll notice here on this one, out of these two equations, the bottom one is going to be simpler to solve, and it's going to be easier to solve for y on this one. So unlike the first one, I solved for x because it was easier. Now I'm going to solve for y because it's easier. So if I need to move this 8x over, I'm going to add that 8x over. So I have negative y equals 25 plus 8x. And now this is a negative. Pretend there's a 1 in there. So I need to divide all of this by negative 1. So y is going to equal negative 25 minus 8x. Because I divided by that negative 1. So now that's what y equals. And again, I'm going to cross out this bottom one because I don't use that one anymore. And since I figured out what y is, now I substitute it back into the other one. So I need to use this other equation of 2x plus 3y equals 2. Again, I know what y is. I solved it. It's negative 25 minus 8x. So I'm going to plug that in for y. So I have 2x plus 3 times negative 25 minus 8x. And that's going to equal 2. Now I just do what I learned in Math 1, distribute here. That's going to be negative 75 minus 24x equals 2. and combine my like terms. I have 2x minus 24x, which makes negative 22x, minus the 75 here, equals 2. Add the 75 over. So I have negative 22x equals 77. And now to get x by itself, I'm going to divide by negative 22 on both sides. And then reduce that. The fraction is going to be 7/2. So x equals negative 7/2. Now again, that's only x. And with this system we have two answers, so I need to plug this x back in to get y. Well, I know y is negative 25 minus 8x, so I'm going to use that equation to get my y. So y equals negative 25 minus 8x, and for x I'm going to plug in negative 7/2 now. So y equals negative 25 minus 8 times negative 7/2. Again, if we go to our calculator, scoot that over so you can see it. If we go to our calculator, I can punch in negative 25 minus 8 times negative 7/2, just like it says on my paper, and I get 3. So y equals 3. So the answer to this system is y equals 3 and x equals negative 7/2. And that's how you solve using the substitution method.